that we all have all this data. When we are done with the session, you'll be able to like refer back to this and all that. Question 6, right? It's a trigonometry question. We can see it. It's there in the open. Nothing crazy, really. It says in the diagram, right? Wait, in the diagram are the graphs of f and h. So in this diagram, right, you have h and f, right? So let's see here. F is our sine graph. H is our cos graph. Now the thing with trig functions is, like, I kid you not, you need to know your theory. If you don't know your trig functions theory, you are going to have a problem, because your trig functions theory is what makes you dangerous, you know. So if you ever need a scenario where you need to go through like the basics of that, you can always just hit me up, and then I'll always be able to like send you links of where to find all that stuff. But anyways, it's a sine graph and a cos graph. Now, very basic stuff, right? Things like knowing what the 2 means. If you don't know what the 2 means, yeah, you know, it means you just need to just go to the basics, because the 2 here means frequency. And then I think I've mentioned this before. It means frequency, and it is equal to, what is this? To 360 divided by the period. See, and I'm getting a phone call, and yeah, it is definitely important. So excuse me, I'm just gonna, let's just get on with our question. So let me see here. Do I need to add anyone? Yep, I need to add Sembo. Anyways, we were mentioning that, okay, f of x is equal to sine 2x, right? The 2 here stands for frequency, and frequency has a formula, you see. Frequency refers to how many times you are going to see your graph in a space of 360 degrees. So putting it simply, right, you can see this is f of x. This is the graph of f. If you look closely, between negative 180 until positive 180, that's a space of 180 degrees. You see, it's a space of 180 degrees. Now, no, this is a space of 180 and then a space of 180 again. So in a space of 360 degrees, you can see you have 2 full graphs, because you have like one full sine graph over here, and then it stops, and then you have another full sine graph. You see, so your 2 here is it's telling you that you have 2 full graphs in a space of 360. The period is how long it takes to have a full graph. So the frequency is a 2, frequency here is equal to a 2, but then the period is just 180 degrees. The reason why the period is 180 degrees is because you are seeing a full graph in a space of 180 degrees. You could even have just used the formula. You see, frequency is a 2, so if you need the period, you'd have just said here times by p here, times by p here, you'd have like 2p here. These p's cancel out, and then you'd have like 360. Divide by 2 on both sides, you'd have p is 180. You see, so if you don't have a picture, you'll always be able to work it out algebraically. Anyways, write down the period of f. No, we didn't even finish reading the question. H is the cos graph. This is just saying a standard cos graph was moved 45 degrees to the right. So don't take that for granted. There are certain things that over time you need to be able to know by intuition. So if this is 0 and this is 90, directly in the middle here, right, you need to know that this is 45, you know, and then directly in the middle here, you know that this is negative 45. It's not you guessing, it's not you making assumptions, those are facts, you see. And you should also know this is a space of 45, space of 45, also another space of 45, meaning this is like 135, you see. And then meaning that this is going to be negative 135. Not to say you should put it, I'm just saying you should know it, because it all is going to link together. So if you see that this cos graph was moved 45 degrees to the right, it kind of makes sense, because normally with a standard cos graph, right, we're used to seeing maybe in a space of 360 something that looks like this, and then on the left maybe something that looks like this. So if the whole image is like moved 45 degrees to the what you may call the right, we would expect it to not be passing our y-axis where it turns, you see, which is exactly what's happening for our course graph over here. You see, we're only seeing a portion of it, but it's our course graph, you see. The only thing is the scale is what is making this look a bit weird, you see. But this is a portion of a course graph, you see, this pink line here. Because what we're seeing here is technically something like just this, you know, something like just this part here. Let me maybe use like a green to like highlight it, or let me use the bright green. So me doing all this blabbing, yeah, it is for a reason, because a lot of what we're gonna do is based on us understanding these sketches. So that being said, they said it's for the interval -180 to +180, and then they said A is a coordinate that we're given. Where is A? A is down here. And also take note of how whatever we're going through in the description, we are really not rushing anywhere. We're not rushing anywhere, not because we are not writing a test. That's not the reason. The reason we're not rushing anywhere while reading the description is you might as well spend time analyzing your sketch and your description before you dive into questions. Otherwise, you'll miss very simple things that they'll be giving you. So them telling you that A is a minimum point, they're trying to affirm that this is a turning point, right? A. And then it says here, and C is this point. They're also trying to have you know that, yes, this is definitely a turning point. X value is 45, Y values are 1. So also you now know that, okay, these graphs go all the way to +1. Your turning point is telling you that. And this other turning point here, you can see that your graphs go to -1. So you're now certain this is 1 and -1. You're also certain that your amplitude is a 1. You see, because remember, amplitude, it's just a formula. You see, your amplitude, oh goodness, let me see here. Amplitude is equal to the maximum y minus the minimum y. Oh, why am I writing so small? Shouldn't be doing this, bro. You should be having an abundance mentality. You're busy writing in a small space. What is wrong with you? Let me see here. Let me remove this. So amplitude is equal to the maximum y value minus the minimum y value, the whole thing over 2. So here you would have 1 minus -1 over 2. This is like 2 over 2, which is a 1. So you'll know the amplitude is a 1. But then your equations are also showing you that your amplitudes for your graphs, it's just a 1, because the number in front here is always what gives you your amplitude. So excuse me for just mentioning all these basics. Yeah, we're just trying to reinforce how important some of that information is. So all this being said, they say they are A and C, it's the maximum value on both graphs. So C is the maximum value on both graphs over there. And then it says the two graphs intersect at B, C, and D. Let's see. B, it's a point. They haven't given it to us. C, they gave it to us. D, they haven't given it to us. So two of these are not given, and then one is given. So that's interesting. Okay, all that being said, oh wait, no, D, they wrote it. D, they gave us. It's only one coordinate that they didn't give us, which is B. So let's just carry on. Let's just see here, 165.5. So the sketch may look a bit messy right now, but it's just all information that we should be able to use. We should thrive in chaos. So without wasting any more time, they're asking for the period of f. And we've already dealt with the period of f as we discussed. The period of f comes from your equation and your sketch. You can either look with your sketch, get your 1 mark, or work it out with your equation and still get your 1 mark. You see, we said in the equation, you're just going to throw the period as 180. No. You're just going to throw the frequency as a 2 and then solve for the period, of which here we got it as 180 degrees. So there's really nothing crazy about this 1 mark question. It's a 3 mark question, and you should always be able to go get that mark. The reason why B is a 1 mark question is because with B, you don't have to use too much logic with B. With B, you need to use your picture. Your picture is what is giving you the value of B, or the coordinate of B. Because you don't overthink it. Let me even zoom in here so that you can see this nicely. If we're zoomed in here, right, what you can see nicely is that this portion of our image is symmetrical. What we're seeing on the left side here is exactly the same as what we're seeing on the right hand side. It's symmetrical. In the middle, you have 45, right? So we can see that from 45 all the way to the left here, this is like a space of 90 degrees. And then same thing is happening here. From 45 in the middle here to like 135, that's a space of 90 degrees. All that we know. Another thing is from 0 to 45 here, this is like 45 degrees. From 45 to 90, that's like 45 degrees. So you want to use that way of thinking to help you see what B could be. Because if you look at where B is, you can just use D to help you, because this image is symmetrical on the left and on the right. So what you can do for yourself, firstly, I mean, logically speaking, and this is where you don't want to overthink anything. The Y value of D is going to be the Y value of B, you know? So whatever the Y value of D is, it's exactly the same as the Y value of B. So that's going to give us the Y value of B, because this sketch is symmetrical. Furthermore, if you look at the distance,
can I say
yeah,
something?
yeah, anytime, madam, anytime.
Even though that you saying it's symmetrical, but you need to check with the signs. The B, that half, isn't it gonna be negative half because it's on that side?
Ah, you're thinking of the X value. Because
No, I mean
remember,
of the Y value.
yeah, we haven't gotten the X yet.
Okay.
But then if you look at the Y values, remember the Y values, this is oh wait, I think I wrote it incorrectly. There's a negative a half here. Oh yeah, I see what you mean. Yes, 100%. I was just being hot-headed. I was being hot-headed. So let me just put that there. But I think, let me do this. I'm getting that call again. I'm just gonna leave this screen, right, so that you can try and figure out the X value. And then I'm just gonna pause the video, and then I'm just gonna come back now. You can just try and figure out what B is, and then I'll be back now. Let me just mute my mic for a second. Right. So with this question, this is how you're gonna get the X value of B. You just want to compare, for example, this small distance here. You see, from this X value, right, until the X value of D, it's like from 135 until 165. So you want to find out what's the distance here. The distance there is just 30 degrees. It just means that the distance here is also going to be 30 degrees, but towards the left side, you see. Because if this X value here is like 135, right, and this X value is like 165, the distance is 30. So here, if the X value here is like negative 45, this has to be 3 to the left, meaning this has to be negative 75, you see. So the X value here is going to be negative 75. There we go. Do you see it? Or are there any questions as to why we have put negative 75 over there? Let me even use, negative 45 minus going 30 to the left, you're going to end up at negative 75. So if there are any questions, feel free to let me know, but I don't think there are any questions here. So I think whatever we've said has made sense, which is good, If there are any questions, you can always just switch on your mic and you can always just ask questions. So yeah, man, don't worry about it. No. Oh, I hear Mike. Yay, what's up?
So my question is there a specific way to calculate it, or we just have to look at the sketch and just like analyze the sketch, and then that's how we get the answer?
100%. The sketch is what's giving us our answers. And there's a reason why they also made this a 1-mark question, mainly because of the sketch, because they know we don't need to do any funny calculation of some sort. It's just one of those things where, remember, your sketches are to scale. It's not random, you see. So in as much as you can see that, and unfortunately, I think we can all agree that this portion of the sketch is definitely symmetrical. So that's the fortunate thing, and I think that's the easiest way to just answer the question. Cool. Okay, moving on. Let's see. 6.3 is for 4 marks. It says use the graphs to solve this inequality for the interval negative 180 to 180. So I mean, like, I reacted the way I reacted because I mean, why not? You know, it's like it's a weird looking question. If a question looks weird, dude, it looks weird. You know, you don't have to, I don't know, act like a robot and be like, I don't know. If it looks weird, it looks weird. It just doesn't mean that you should I don't know, just leave it or be scared. No, no, no. You must stand your ground. You must stand your ground and fight. Okay, that's not necessarily the easiest, I mean the nicest or prettiest analogy, but that's the idea, you know, because the more afraid you are of questions, the less likely you are going to want to attempt them in the first place. So they're just questions, you know. Even if we end up not figuring it out now, it doesn't matter. We're just going to always come back to it at some point. But the thing is, don't just take questions the way they give you. Always, your assumptions, right, are valid if you can back them up. For example, they said use the graphs. So we have these graphs, right? And the thing with them saying use the graphs, we have to take note of certain things about these graphs, of which those certain things are things like the sketches and the equations of our graphs. So the equations of our graphs, firstly, we know this one has a sine graph, this one is a cos graph. Now, the other fortunate thing that we can also not ignore here is the fact that this 2 sine x cos x is definitely a double angle. So that's like one foot in the door in terms of us answering our question. And I'll repeat what I said. When you're going to answer questions, don't just take what you're given and use that. Rewrite it whichever way you know may help. Using this like this is certainly, it doesn't look like it's going to help. Using it like this seems like it might help with something. So let's put this inequality sign here. And then the other thing, for some odd reason, like I don't wanna seem extra, but for some odd reason, my intuition is telling me that, okay, wait a minute, there's just a lot going on in my head. One of the things that are going on in my head is I'm thinking of how this second equation has 45 there somewhere. Let me just put this nicely somewhere. This second equation, we can see there's a 45 somewhere here. Negative 45, right? Now, the fortunate thing with this negative 45 or the degree 45 on its own, it's just going to remind us of our right angled triangle, this one, you know. So this 45 here and this number 1 over square root of 2, in my head, this is what I'm already thinking of. I'm thinking of this special triangle because this special triangle has 1 and 1 here and it has square root of 2 here. Now, apart from just thinking of this cos x plus this sine x and the 1 over square root of 2 outside, for some odd reason, by intuition, it seems like it's going to be a good idea if we like multiply inside our bracket. The reason for multiplying inside our bracket is because we're going to end up with something like this: 1 over square root of 2 with cos x, and then 1 over square root of 2 with sine x. Now, further psychoanalyzing this, what we know is 1 over square root of 2 is the same as cos 45 or sine 45. I'll repeat. 1 over square root of 2 is the same as cos 45 or sine 45. Let me just add our fallen comrade. Now let's rejoin our fallen comrade. So that's the reason behind why I'm thinking all that I'm thinking. Or I'll give a rundown of the train of thought, you know. So from the get-go, they said in the diagram, no, they said use the graphs. So we are saying, if they're saying use the graphs, concentrate on things like the equations and the sketch, if that can help you. Of which the sketch will help. Well, the sketch, it looks like the sketch is going to help us, what you may call, a bit later. The sketch seems like it's going to help us a bit later. But before we can worry about the sketch, this has so many clues in it. And we're saying we want to use it just the way it is. And me having to have written out what I've written out, I mean, I'm pretty sure there's most of us are like, oh, I think I see where this is going. Because even from the beginning, right, let me just rewrite what we had. We had 2 sine x cos x, where is this smaller or equal to 1 over square root of 2, and then there's cos x plus sine x. So the issue is these two sides of our inequality sign, we need to write them in a way that relates to our equations. So thinking of cos x minus 45 and thinking of sine 2x, one thing we know is sine 2x is the same as 2 sine x cos x. Another thing is cos x minus 45. This is a compound angle. And this compound angle, I mean, because I don't cram this whole compound angle stuff, like literally, I just always go to the formula sheet, because you can imagine I'm not like always necessarily like working on trigonometry. So things like the compound angle formulas, I literally just don't know them. I just have to look at the formula sheet all the time, which is something I'm like 100% comfortable doing, because it's a reminder that some things you don't have to cram them. So all I need now is the cos compound angle, the one with the negative in the middle. So you see here, cos an angle minus something, it's cos cos with a plus, and then sine sine. So what we already know from that is that what we're seeing in our question here, cos x minus 45 is the same as cos cos, and then with a plus, and then we have sine sine. There we go. So that's one thing we should just be seeing. From just seeing this, right, we should be seeing that, okay, wait a minute, they want us to use our graphs to solve this equation. But then with this inequality question, I mean, the graphs that we have, right, there's not something that's directly linked to it. So we need to make sure that what we have here, we link it to these two images or these two equations. And this looks like one way we're going to do it. Where we see the 2 sine x cos x, we're going to rewrite it as sine 2x, because that's a double angle. And then one way or the other, we say it here where we see the 1 over square root of 2. The 1 over square root of 2 should remind you of your 45 triangle. And what we know about our 45 triangle is that cos 45 is 1 over square root of 2, and then sine 45 is also 1 over square root of 2. So it's like a lot to take in, right? But then without like saying too much unnecessarily, let's just be writing out what we know, right? I'll just try it. I think as I'll be writing it again, it will click. So here where we see 2 sine cos x, we can put there sine 2x. And then where we see the half square root of 2, without maybe debating whether to put a cos 45 here or a sine 45 here, what you can do for yourself is firstly multiply inside your bracket, right? You're going to have 1 square root of 2 there with cos x, and then 1 square root of 2 there with sine x. Now, what you already know is what we have on the right-hand side here. We want to, whatever, this is what they gave us originally, but this is where we are now. And we're trying to eventually write this in a way that shows that it is actually our cos graph. So one way to do it now is where we see the 1 square root of 2 here, based on what we wrote over here, or based on what we know, right, about the equation we're trying to get, based on what we know. Because we have cos x and cos 45 here, it looks like we may have to put this as cos 45. You see, we'll put this as cos 45. So we can even rewrite it like this now, cos x with cos 45. And then based on what we're seeing here, right, it looks as though where we see the 1 over square root of 2 here, we'll write that as like sine 45, because they are both equal to 1 over square root of 2. Cos 45 is the same as 1 over square root of 2. Sine 45 is the same as 1 over square root of 2. So this is the second step in us going from this to something useful. And then lastly here, we can see that, okay, fine. On the left side, everything is done here. But then on the right-hand side here, we can now see that whatever we have written out here, we can now just write it as our equation of our cos graph. Now, as long as we have written our question out from this to this, we, out of the 4 marks, you can practically say you have it at least 2 marks out of the 4, because it's not an easy task. Okay, it's not like very simple or whatever, but it's not like a very easy task for us to always remember that if they ask you to use the graphs, don't deviate to something away from what you're given. So you can see that the task here was for us to take what they have given us as the question here, and then try to rewrite it in a way that represents the equations were given. And that's like usually how these questions are set out. And when I say usually, I should actually just re-emphasize that and say like 90% of the time or 99% of the time. Because when they ask you to do things like using the diagram and whatever, those are hints that should not be ignored, you see. So what I'm trying to say is now we can clearly see what the question is asking here. This question is saying, firstly, the sine graph is for f, the cos graph is for h. So this question is literally saying, where are the y values of f smaller or equal to the y values of h? That's what this main question is asking you. In as much as it is masked as this weird thing, blah, 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 this is all they're asking. If you're looking at your picture, where are the y values of f below or equal to the y values of h? So to answer that question, I mean, the easiest thing you can do for yourself is, firstly, just go to where the y values are equal. You know, the y values of your graph here, they are equal over there, equal over there, equal over there, you see. So you can easily now make a comparison of the y values. So where is f? F is this graph here. It's the sine graph. Let's highlight where h is so we don't get confused. H is this graph here. Perfect. This is f and h. Now we just want cases where the graph of f has lower y values than the graph of h. So let's see the graph of f, where does it have lower y values than the graph of h? So it's just a matter of looking at your picture. If you look at this portion of your picture, remember you always compare them directly according to like the x value. So you compare based on where each x value is. So the x value of both graphs, if it's the same x value, what is the y value for the one graph? What is the y value for the other graph? That's how you make a comparison. So just by looking at this portion of the sketch, you can see that the y values of f here, they are above the y values of h, you see. So everywhere on this portion of the sketch, all the way until this part where they meet, we can see that this portion does not qualify for our question, because our question wants us to work out where the y values of f are smaller than the y values of h. So this portion of our sketch does not qualify. Only until here, only from here, right, all the way until somewhere there. If you look at these y values of f here, all these y values of f here, all of these y values of f, these are all y values of f that are below the y values of h. You see, so this portion of our sketch here qualifies for our answer. So what we know is specifically from this x value here all the way until this x value here, for now, that qualifies for our answer. But then if we carry on, right, it looks as though this portion also qualifies for our answer, because all these portions here, the y values of f are still below the graph of h. You see, they're still down there, and we can see it. You see there, it's down here, down here, down here, everywhere here, all the way from this x value up until whatever this x value is. This is the portion that is answering the question they're asking us. You see, because if you look at the question is literally asking for interval. They said use the graphs to solve this inequality, right, for the interval where x is between -180 to +180. So what they will be saying is along the x-axis, if you're looking at the x values, which x values do you see that are producing y values of f that are below the y values of h? I think that's more like a weird way of saying it. It just means if you're looking at your sketch from left to right, which portion of your sketch do you see the y values of f being lower than the y values of h? And we're seeing it's from this x value here, which we know from our, you know, our mini sketches and everything. We know that this x value here, we got it to be like -75. So let's put here -75. This x value here, we got it to be negative positive 165. What we're concerned with is just the x values. So for this question here, out of 4, we're going to say the answer is from this x value to this x value, meaning we can say something like x is an element of negative 75 up until positive 165. We're putting square brackets on both sides because this question said where is it smaller or equal to, you see. So it's here they're equal to each other, here they're also equal to each other. So that's why we're including them in our solutions. And then every x value between that is the portion where the one graph is below the other one. So that's that for this 4-mark question. You can see there's a reason why this 4-mark question is right at the end of, is it a 4-mark question? Yeah, it's a 4-mark question. I think the 6 is more to say, what is the 6 for? The 6 is the total of everything. The 4-mark question is what we've just looked at now. So if there are any questions on this 4-mark question, feel free to ask, and then we shall answer the questions. But it doesn't look like there are any questions. So is good, is good, is good. So we shall move on to the next question, but let me maybe stop this for now, just in case. Just do this. Hi, woman. When's in Johnny? When's in Johnny?